everyone to this beautiful and wonderful morning. Hope all of you are good and healthy. Welcome to the webinar on latest trends in structural repairs and retrofit in India, conducted by Civil Engineering Department, TSSMS Bhivrabai Sawant College of Engineering and Research, Nare, Pune, in coordination with Institution of Engineers, Solapur Local Center. My name is Pooja Shamrao Kondhalkar, studying in third year of Civil Engineering. I would like to welcome all the dignitaries and Chairman Engineer S.M. Sheikh Sir, Principal VVP Polytechnic Solapur, Secretary IEI SLC, Engineer M.S. Deshpande Sir, Executive Director Bharat Ratna Indira Gandhi College of Engineering Solapur. Today's expert Mr. Vivek S.V. Sir, Dr. G.A. Hinge Sir, Principal of Bhivrabai Sawant College of Engineering and Research, Professor A.P. Khatri Sir, HOD of Civil Engineering Department, Professor K.S. Bhosle Ma'am, Faculty Coordinator and participants. We will start our program with Saraswati Vandana.
या कुन्देन्दु तुषारहारधवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा शुक्लां ब्रह्मविचारसारपरमा जगद्व्यापिनीं वीणा पुस्तकधारिणीम् अभयदां जाड्यान्धकारापहां हस्ते स्फाटिकमालिकां विदधतीं पद्मासने संस्थितां वन्दे तां परमेश्वरीं भगवतीं बुद्धिप्रदां शारदाम्.
Now I request our principal, Dr. Hinge Sir, to address the gathering.
Thank you. On behalf of JSPM and TSSM Group of Institutes and Bhivrabai Sawant College of Engineering and Research, Nare, Pune, I welcome the officials of Institution of Engineers, Solapur Local Chapter, Chairman Engineer S.M. Sheikh, Secretary Engineer M.S. Deshpande, Mr. Vivek S.V. At the outset, I would like to congratulate Department of Civil Engineering, DSCR also, for subsequently arranging this second lecture in this series. And today's topic is also very vital for the civil engineering fraternity. Recently, I had an opportunity to attend one of the seminars in Pune, and the topic was dedicated to concrete yesterday, today, and tomorrow. So there is one of the companies in Pune which has developed a new concrete. The specialty of this concrete is that it doesn't have any steel bars, it doesn't have any aggregates, crushed sand, cement, admixtures, water, and the steel fibers. These are the only ingredients, and they have achieved so that that is something like a dream come true. And they are using this concrete for manufacturing the girders of a bridge. Now, the maximum length of single girder that they have achieved and implemented on field is 60 meter, and they have planned to go for 100 meter, that is single length of girder. Now, by way of this invention, mainly they are going to reduce the number of piers, which otherwise occupy a number of positions across the river, and this is really going to bring a revolution in the field of concrete. And like that, there are many incidences is coming up, and I would say inventions which are coming up, mainly the retrofitting and repairs of concrete structures. It becomes a very important issue, especially in the era of whenever it encounters with the earth due to various reasons. And I hope today's expert will throw more light on this aspect. It will be a learning experience for the audience. So once again, I welcome all the experts and thank you for giving me an opportunity. Thank you.
Thank you, sir. My name is Manoj Mate. I am studying in third years in civil engineering. I am here to introduce our today's expert, Engineer Vivek SP sir. Sir has completed a bachelor's civil engineering from National Institute of Technology, Calicut, Kerala. He also completed a master's infrastructure design and management from Indian Institute of Technology, Kharagpur, West Bengal. He was intern at Airport Authority of India, Trivandrum. Also intern at L&T ECC Technopark, Trivandrum. He worked as project executive and assistant manager at Total Environment, Bangalore. Currently, he is working as manager of retrofitting at Sarrachana Structural Strengthening Private Limited since 2019. He handled different job responsibilities as project executive at site, execution of all civil engineering works from walling layout to handover of luxury smart homes, up to testing and commissioning of all services from plumbing to home automation and centralized vacuum. As site project management officer, early budget estimation for the project, including monthly fund allocation and planning based on BOQ, presenting the progress review, billing of contract works and overheads, ensuring workplace safety and inside housekeeping through monthly safety audit and delivering toolbox talks, QA QCs off-site education and materials, customer relations management as site. As a manager of retrofitting in Sanrachana, structural design of retrofitting for bridges, buildings, water tanks, etc. Improvising structural design through programming and spreadsheet, boosting business development through detailed 3D modeling, promo videos and presentations on retrofitting, computer proficiency, SAP, StatPro, Python, HTML, JavaScript, Palomera, MS Office, SketchUp, and Abacus. His key achievements are develop 8 programs in JavaScript, HTML, 3 in Python, and 1 Windows app for FRP-based retrofitting. They performed structural design for relative big projects, prepared 3D models and videos projects that are in public domain bearing the name of the company. Handed over 1 triplex and 4 duplex luxury smart homes. Performed Indian painted rating of basements and ramps. Worked for Future of Cities, MHRD project of revival of Varanasi alongside Columbia, USA. Create international occupational safety qualification with destination. With this brief introduction, I request Mr. Vivek sir to deliver the session.
Thanks to Professor Kirti Bhosle and all the dignitaries of Engineering Institute and all the participants. Thank you for this great opportunity for me to talk to you all about structural strengthening, and thanks for the elaborate introduction. So today I intend to present a short presentation about the latest trends in structural repairs and retrofit which we follow in India. Let me start with the basic learning objectives that we intend through this presentation. So we will learn why retrofitting is required. When retrofitting, I'm talking about structural retrofitting, and what materials are typically used in our retrofitting projects in India. FRP based retrofitting, we will learn about contact critical and bond critical applications, and how are the retrofitting solutions designed for particular site requirements. We will look into that, some sample design calculations, as well as a few case studies of retrofitting projects. Okay, so let's just jump in directly into why retrofitting is required. So change in use. Okay, what is change in use? Like when a structure was once built for a given purpose, and then the purpose of that building changes, like a residential part of a residential complex is becoming a commercial setup. So wherein new additional loading, which was originally not intended to be acted on that particular structure. Okay, so that kind of scenarios happen wherein the purpose of the building is changing. At that case, the amount of loading that appears on the building changes, which was not designed, which it was not designed for originally. So in that cases, we need strengthening of the building. That is change in use. When new equipments or seismic retrofitting is required, as in like seismic load was not considered, but now we need to consider to to comply with the design codes, etc. Deterioration, age deteriorates everything. Like as years pass by, corrosion happens in the RCC structure, steel structure as well. Loss of sectional area, okay, by some kind of impact or any other reason. Loss of cross-sectional area of material members, structural members, cracking, and exposure to environmental weathering factors. Okay, so those contribute into the deterioration, which makes the structure weak. So wherein we require retrofitting. Faulty construction, wherein say if you're constructing a slab, you require say 20 number of steel rebars in the main direction, but at the time they put only 16 numbers of rebars. So in missing reinforcement is that case. Incorrect reinforcement details, like the spacing that was written as 150 mm center to center, misread at the site as 200 mm center to center, a kind of incorrect retrofitting reinforcing details. Low concrete strength at the time of construction, or like when you require M30 as per design, but in site what was poured was M15 concrete. So that kind of scenarios. Okay, and the structural damage directly as per because of fire, etc. All right. So in these kind of cases, we require retrofitting. This is why retrofitting is required in the construction industry across the world. Now, these are just a few textbook categorization of retrofitting techniques. Let us concentrate on the materials used here. Okay, FRP wraps. FRP stands for fiber reinforced polymer. Okay, a wrap as in it's in the form of fabric which can be wrapped around the structure. FRP laminates is strengthened as in it will be in a stiffer form. It will not be in the form of a fabric. So you just need to attach this laminate onto the structural member as per design. So that is factory cured FRP is FRP laminate. And then NSM, which is near surface mounting. All right. This is again a technique that is elaborated in ACI, which is American Concrete Institute's codes, design codes, like we have IS codes. Okay. They have ACI codes in America. So they, coming back to the materials used, we have structural steel. For retrofitting, we use structural steel as well, as in steel members of ISMB 200, ISMB 300, channel sections, etc. High strength alloy plates, which is something that we use frequently, which is FE 450 grade alloy plates or FE 500 grade alloy plates required, designed as per the requirement of the site. All right. Another is wherein huge amount of strengthening is required, or wherein the the amount of budget that you can allocate is lesser as compared to FRP, or wherein you don't mind losing a little bit of floor area. Okay, when it is a residential project in the modern times, you cannot widen the cross-sectional area of a column, because that will become a court case if you advertise that the cross-sectional area, floor area of a flat is so and so. If you advertise it as 450 square meters and you provide lesser than that, then it is a legal issue, because of which you have to go through FRP methods or any other hybrid methods. So if that kind of restriction is not there, then you can go for the conventional method, wherein you can do jacketing of the columns or beams, or whichever member we require to strengthen, wherein we use FE 500 or 550, which is the steel rebars which we use for general construction. Microconcrete, which is a concrete that contains lesser size aggregate. When I say aggregate, I mean the coarse aggregate. The cross-sectional area of the grade of the coarse aggregate used in microconcrete can be 20 mm down or even 10 mm down. Okay, and inside we add a 20 mm down aggregate, but I think it comes commercially with a 10 mm down aggregate, as in the maximum size of aggregate used in the microconcrete is less than 10 mm. And you can even use regular RCC if the quantity is too high, because microconcrete is a very specialized material and it will it will be costlier as compared to the regular RMC concrete that you see, like the one that comes in the transit mixers. All right. And external post tensioning can also be done for, especially for beams and slabs, for which we use FRP laminates, which post tensioning cables, the one that we typically use for the fresh constructions, wherein you provide the post tensioning profile and then you post tension by using jacking on either sides. Then you have hybrid solution. So we will go into all these in detail in our presentation, but this primarily gets you introduced into the materials that we typically use, especially in India, for retrofitting projects. And you know the advantages of FRP. This is just a second. I'm still connected. Yeah. So basically, it doesn't corrode because it is fibers, and the fibers are made out of carbon or glass, or you have aramid as well. Okay, so these are non-corroding, non-metallic fibers, and they have very high ultimate strength. We have high elastic modulus materials also. Like lot of advantages are there. It is clean application. It is lightweight, so it can easily be applied. So it doesn't add dead weight onto the structure, unlike when you add when you do jacketing. So jacketing requires a lot of concrete and steel, right? So it will add a lot of dead load to the structure. When you apply it into the higher floors of the building, it will add a lot of load on the bottom members. And the disadvantages of using FRP, a few of them you need to really know that it cannot be used as a directly used as a compressive strengthening method, like axial compression. ACI does not recommend using FRP. Okay, so FRP is a very good material for flexure as well as for shear. But for axial compression, unless it is a circular building wherein the mechanism is different, mechanism is through hoop strengthening. If it is not providable by, if the cross section of the column is not circular, then typically we don't use FRP for axial compressive strengthening. Okay, we will look into this in detail in further slides. All right, so basically what is FRP made of? It has a fiber face, okay, as well as a matrix face. What is a fiber face? The fiber phase is the strength provider, okay, of FRP. The strength provider of FRP. It could be carbon, it could be aramid, it could be glass, Kevlar, boron, etc. These are the fibers that can be used. There are pitch and pan fibers in carbon fiber, depending on the requirement, whether we need high elastic modulus or high strength. You can select pitch or pan. Again, similarly, glass fiber. And now coming to the matrix phase, you have thermosetting resin and thermoplast resin, which is also, selected based on the type of application. Okay. So before we go into this, I would like to appear in video so that I can show you a few. This is carbon fiber laminate. Okay, this is how it appears. Fibers oriented along one direction. More clear this way, right? Yeah. Carbon fiber, and this is the thickness. You can see it is quite thin. All right, you have glass fiber laminate that looks like this. The color is so because of the epoxy used for setting. This is also glass fiber laminate. Okay, this is a different resin that was used at the factory curing stage. All of these have fibers oriented along one direction. So you can see the grain pattern along one direction. These are laminates. All right. Now there are carbon fibers, carbon fiber wrap that I was talking to you about. This is how it looks like. It is basically a like a fabric, very flexible. This has fibers oriented along one direction. So it's a UD fiber. Okay. We use it typically for shear strengthening. Sometimes for even flexural strengthening. We will see how it is applied that way. Okay, this is these are categorized based on their weight, as in the count of number of fibers is categorized based on its GSM capacity, that is grams per square meter, GSM. So higher the GSM, more the fibers that you get. So this is basically a 900 GSM, no, 600 GSM carbon fiber. And this is 900 GSM, which is a little bit thicker. You may not be able to see, but to feel it is thicker. Okay. And then we have the glass fiber FRP. Okay, this is how it looks like. You can see the fibers in here. All right. It's again one. It is bidirectional. See, now if you look carefully, you can see that there are fibers running in both directions. So the side facing you has fibers fibers in this direction, in the vertical direction. And if I flip it around, you can see fibers in the horizontal direction. Okay, so this is a bidirectional fiber. And we also have certain things like this. This is used for this is used along with matrix, a special cementitious matrix. So this is a mesh of carbon fiber, bidirectional, both directions there are fibers. And this is basically a part of, this is basically the strength provider of a product called as FRCM, fiber reinforced cementitious matrix. So you apply this onto the structure in whichever, as per the design, okay, and then you fix it permanently to the structure using specially designed mortars. We also have carbon fiber rods. This is how they look like. This is a carbon fiber rod. This is a glass fiber rod. All right. So typically carbon fiber rods will be black in color because carbon is black. In this fiber form, carbon is black. Of course, diamond is also carbon, which is colorless. This is glass fiber, and the color can vary based on the epoxy used. Okay. So these are how this you can sounds like ceramic. Okay. This is how it is. So this is one typical project wherein we have done FRP strengthening. This is this Lisa Pointer. So this is the bridge which is across the river, and there are several piers which are deficient in shear. Okay, so these are like 2.3 meter by 1.9 meter cross section, like huge piers are there. You can see the size of the pier with respect to the 4-lane highway. Okay, so for this we initially, it was not designed as per the seismic requirement, but later on we needed to comply with the seismic. The builder was required to make it comply to the seismic requirement. So because of which this cross-sectional area, you can see the number of bars, like huge cross-section, wherein number of stirrups which was provided at the construction phase was less as compared to what is required as per the earthquake seismic code. So for that, we designed the carbon fiber wrapping for increasing the shear strength of the section. So this is how we did it. You can see a roll of carbon fiber here. Okay, this equipment you see on the right is called a wet layup machine. Okay, you have a FRP wrap here, FRP roll here. It gets dipped into the epoxy resin. Okay, it comes out fully saturated and becomes a saturated roll of FRP here, and this goes into direct application. Okay, so that is a wet layup machine. So basically the design is like this. You have the pier here, and just a second, let me erase the. Okay, I cannot erase that. Okay, ignore this red line. All right, so you have this column, you have this pier. Basically, we are increasing the shear strength. Okay, so we have this fiber. It is unidirectional. The fiber length. Along the fiber length, you have along the length of the roll, you have the fibers. So this is the direction. Green shows the direction of fibers. Okay, as per calculation, 4 layers of this 600 GSM carbon fiber was found sufficient for compensating the deficiency. Okay, so this is the stage 2. After doing this FRP wrapping, like 4 layers of carbon fiber all around the column, what you need to do is protect the FRP. Okay, because it's a river, there are a lot of floating objects coming from the river, and it will directly come and impact the FRP, and it will damage the fibers. Then it is of no use. So for that, you paste washed silica sand on top of the surface of the FRP like this. You can see, and this is for providing the grip. Okay, grip into what? Because we are doing microconcreting. So we have a 40 thickness microconcrete, which you can see is being poured into the pier. So for the microconcrete to have a bond with the FRP that is inside, you applied the previous sand layer. This is for shear strengthening of this project. And we had to see, basically, site execution is more difficult than how we assume. In this particular site, the daylight hours are very limited. The temperature is low. The amount of rainfall that happens based on the rainy season, you need to plan your retrofitting activity, because once it starts raining, the river will be the height of water in the river will be quite high, and you would not be able to do any retrofitting on the pier because it will be submerged. So all this gave us ultimately 2 months window in a year. Okay, so we could only do the retrofitting work for 2 months in a year for this particular project. So that was the planning. I can see, I told you, right, the piers will get submerged. So you cannot do FRP wrapping on a submerged river, right? So this is what it is. Now, yeah, logistics. So this particular project was running during the COVID times. So a lot of precautions need to be taken, regular health checkup, everything. And it was in a very remote location. So shifting had to be done in these boats, which we have never done before this way. You know, because usually when retrofitting happens in the rivers, it will be dried up. But for this river, it's a perennial river. It's always having water in it, and we have to see where the airport is, where the roadways lead to, etc., so that we can shift our material. So remote locations, it's always very difficult. And again, we need an experimental validation to show the clients, the owner of the bridge, that the FRP wrapping will provide the sufficient strength. So this is how the test setup was done. Testing us, they wanted to correlate the compressive strength increase in compressive strength due to FRP wrapping to select which kind of FRP, which company's FRP they need to want. So this is cylindrical. This test was done in one of the labs of reputed college in Bangalore, in Bombay, and RCC cylinder of the same grade of the pier was cast. 28 days ke baad, after 28 days, FRP wrapping was performed. These are strain gauges were connected to that, and then LVDT is connected to it. And we tested several different samples like this in the same configuration, and also without FRP. So this is a stress strain curve that you're seeing. Okay, strain on the horizontal side and the stress in the vertical side. So up to the strain of 0.01, the FRP was performing. FRP wrapped concrete was performing, and it was going further. Okay, the curve was extending still further, and you can see that it was reaching M70, I think 70 MPa strength, 100 MPa strength, etc. The FRP wrapped concrete. But here you can see that the control group, which is not FRP wrapped, is reaching only up to this much amount of strain, after which it was breaking. We had this curve is the average of 3 different samples, 3 different unwrapped samples, as in plain concrete samples, cylinder strength. So you can see cylinder strength is around 32. That means it might be around M35 or M40 concrete. Okay, so it was only going up to here. So you can see the performance, the drastic increase in performance that you can attain by using FRP wrapping of a circular cross-section member. This is an axial compression. The performance is an axial compression. So yeah, so this is the experimental validation which the client requested. And after this, see, you can see 250,000 square feet. So that is 26,000 square meters of FRP was used, which is a huge quantity used in this project. And here I can show you a video of how it was done. Let me
land of breathtaking scenic beauty, plenteous floras and faunas, plantations, undulating plains, fertile valleys, and mighty waterways. Our retrofitting project is set in this beautiful landscape. This elevated carriageway is an all-weather access passage across the unforgiving terrain beneath it. The carriageway is also a lifeline to the socio-economic development of several states. However, a precautionary structural due diligence by the new owner revealed a red flag. The piers did not comply with the current seismic standards, and the asset location falls under the earthquake zone 5, the most dangerous zone of all. Earthquakes have destroyed even our extraordinary structures. The future of this asset had to be secured from such eventualities. This task was awarded to Sanrachna. At Sanrachna, our innovative structural design team and well-experienced site execution team work hand in hand. Deliver you custom-built turnkey solutions to your structural strengthening and repairing requirements with full load testing. In this project, we enhance the structural performance of the piers with carbon fiber confinement. Here we see carbon fiber being shifted to the piers of the bridge. Carbon fiber FRP is a space-age, high-performance material. Compared to traditional repair techniques, FRP gives tremendous speed of execution and imparts ductility for tackling seismic forces. 250,000 square feet of carbon fiber was applied in this project. After erection and checking of scaffolding, the workforce begins the surface preparation work. Following which, the primer and putty application is done. The saturant is then proportioned, mixed, and poured into the wet layup machine, where it saturates the carbon fiber sheet. Wet layup increases the productivity, pace, and quality. Before doing the protective RCC jacketing, sand pasting is done to improve its bonding. Suspended silt and floating objects in the river constantly impact the piers. We must protect the FRP from erosion and damage. Using the lightweight FRP formwork, a 40 mm thick micro-concrete jacket would be cast with nominal reinforcement. With rebars tied and formworks firmly supported, pouring can begin from the deck to the pier under gravity. And the processes goes on. Time-bound completion means meticulous planning and coordination at site. Based on temperature, the flow of river, rainfall, daylight hours, and resources. Under strict safety measures of COVID-19, our focused workforce gracefully worked their way around the adversities, and with their dedication, the beautiful bridge is now revived and ready to face the challenges of the future. Sanrachna, leaders in structural retrofitting.
So basically, in that project, we had efficiency in the shear strength of the piers. So stirrup quantity was less than what is required, and the solution that we did was FRP wrapping using epoxy-based saturant. Now the question arises: how important is this FRP to RCC bond? Because RCC is a weak member and FRP is the strength provider, and it seems like the bond between this FRP and this RCC is through which all the strength transfer happens. Now, how important is this FRP RCC bond? So to answer that question, we need to know what is a bond critical and contact critical application. So this is the textbook definition for bond critical application, wherein we require flexural and shear strengthening of beams, slabs, columns, or shear walls. Okay, we require this adhesive bond between the FRP and the concrete. Okay, it seems like through common sense, this bond is quite important in all type of FRP applications. However, that's not the case. Okay, there are certain contact critical applications wherein the only critical element in this application is the contact between the FRP and the concrete. Okay, there is no need of bond for this particular type of application called contact critical application. What are they? So see, this is an example of contact critical application. Okay, where the only critical thing is the contact, not the bond. Here is a elevation of a circular cross-section column. Okay, the black that you see is the cross-section, wherein I can show you the section. This is a part of the entire circular cross-section. Okay, so what happens is that the column, when it is under the axial compression, when it is under axial compression, it has a little bit of lateral expansion, right? You know about the Poisson's ratio and all. So because of the lateral expansion, these fibers that are in the hoop direction, which is along the circumferential direction, when those fibers are under this lateral expansion of concrete, they resist this lateral expansion. Okay, because they are in a circle and you are making this, trying to make the circle larger by applying the compression. So those fibers which are along the circumferential direction, in the hoop direction, they prevent, they resist, they don't prevent, they resist this lateral expansion of concrete, and thereby it increases the strength of the concrete. See, basically, if it is not a circular cross section, this hoop directional strengthening will not increase its compressive capacity much. However, it will increase its shear capacity. Okay, so in case of shear, the bond is critical. But if you are applying it for increasing its compressive strength, then the bond is not critical. Only we have to make sure that this contact remains intimate without any air bubbles in between. So typically, this is how we do the column strengthening. So when the column behaves as a beam, okay, like when it is under flexure, combined moment and combined axial force and moment, in that case it will act as a beam. So in that case, to resist the tension side of bending, you apply FRP as a flexural reinforcement in the column, and then when there is a shear requirement, this is how you apply, and combined, this is how it will look like: flexural and shear confinement, shear strengthening, or for confinement. This is the FRP application direction as per theory, and this is how it is in practice as well. You can see that for pure axial compression, this is a clip of ACI 440, which is like, IS 456 is for Indian code for RCC. Here ACI 442 or 17 is the American Standard Institute code for FRP wrapping and FRP laminates as well. So it says that for confining a concrete member, by orienting the fibers transverse to the longitudinal axis of the member, it can increase the compressive strength. The intimate contact between the FRP jacket and the concrete member is critical. So that is a contact critical application. All right. So doing this increases the compressive strength is what the code says, and it is proved as well in the previous charts that I had shown you, previous graph that I showed you. In the experiment, you had seen, right, like higher the M35 concrete was going up to M100 as. So this is another site wherein I had designed retrofitting for 300 or 200 circular cross-section columns. The cross-sectional area was quite large. What happened was that there was a fire incident. So the cylinder strength, which was the design strength of M40, was reduced to M29. Okay, due to the fire incident. And how did they have done the non-destructive testing, which is called as NDT. Okay, so based on that, based on the tests and all, ultimately the consultant had found that the strength of steel rebars are not affected because enough amount of concrete cover was there at the time of design itself. So only the spalling of concrete has happened, and the core concrete strength has somewhat gotten reduced. So the least strength that they observed was M29. So on the safer side, we say all the columns are M29 currently, and we need it to bring it to M40. So this is how it was. Restoration of concrete alone, concrete strength alone is sufficient in this particular case. So what do? Repair the column profile with a high strength adhesive putty, which is a M40 or no, I'm sorry, this is an M50 grade adhesive putty, okay, which was applied to the surface to the spalled areas, so that you need the circular cross section. So when there is spalling, the circle part gets aberrated, right? It doesn't stay smooth. So to smoothen it out and to bring in proper cross section with a proper strong material, you use the high strength adhesive putty, M50 grade, and then you confine it with FRP, carbon fiber FRP. This is the design calculation. I'm not going into the details of design. I'll just show you the specifics, just to make you understand what are the factors in there. There is a CE, which is an environmental reduction factor. You basically reduce the strength of the of FRP by this much, like 4,500 MPa is the maximum strength of ultimate fiber strength, which you reduce by a factor of 0.85 to reach 4,165. And epsilon FU is the strain, ultimate fiber strain, okay, of the FRP, which is again reduced to 0.01445 millimeters per millimeter. So the stress and strain capacities reduced, okay, by this environmental factor. Then your effective strain is again reduced by kappa epsilon, another factor. This restriction is there. It can maximum go up to 0.004. Then you have to see whether there is any effect. The confinement that is provided by the FRP is sufficient or not. So FL is the lateral strain, that is lateral strength that is provided, and F-C is the existing concrete compressive strength. You need this factor to be more than 0.08. And then you have this kappa B, which is a shape factor, which for circular it is 1, circular columns it is 1. Epsilon PCU is the compressive strain, maximum compressive strain, which has to be limited below 0.01. So as per calculation, we were getting up to 0.0065, which is where we limit the FRP's strength providing capacity. And then we see there is this another reduction factor, psi F. For circular, we can take it as 1. FCC dash is the ultimate strength of the wrapped concrete. Now, after application of the FRP, how much is the compressive strength of concrete? We found that after 4 number of FRP wraps, it has come up to 39.12 MPa from 29 MPa. And we submitted the calculation to the clients, and they have certified it. We don't really need to go up to 40 MPa. As per the structural analysis, 39 is well enough, well within the safety limits. So that is how this particular project was designed and later on approved and went on to site application. So in the horizontal direction of application, the overlap required is calculated using this particular formula, which is given in ACI and ACI code, and calculated as 300 mm overlap. So these are the design details. I'm just giving you a brief idea of how it is done. And the one thing that you need to understand is that the ultimate fiber ultimate strength of 4,165 MPa is, see, after application of this environmental factor, we are getting 4,165 MPa. However, in actual practice, we are limiting the strain to 0.004. So if you multiply that with the Young's modulus of the fiber, you get the strain epsilon into E, you will get the strength, right? So ultimately the strength that is provided by the FRP is only 920 MPa. So you can see how much amount of factor of safety is there in the design of FRP. Okay, your material is capable of this much, but you are only allowing this much, 920. It's like 4 times. Why is there so much amount of factor of safety? Because FRP ultimately is not a ductile material. Okay, that is why the high amount of reserve strength is required. High amount of factor of safety is required. Graph of stress versus strain of wrapped concrete FRP strengthened concrete. You can see this is one of the programs that I have done in Python to show the behavior of concrete in FRP wrapped and unwrapped condition. This is the bare concrete, the green curve that you're seeing. Okay, that is M29. It barely braces the M30 line, so it is M29 is the maximum strength with the existing concrete. And then after FRP wrapping, this blue curve is the stress strain performance curve, wherein you have to limit, as discussed earlier, 0.0065 is where you had to restrict the strain as per the calculation, and at that point you are getting around 39 MPa, and that was found sufficient for this particular project. This was the column, and surface you have to grind and finish so that it is only the bare concrete is visible. This is after the spalling repair. Okay, so you can see like a little bit of black patch here, which was smoothened previously. Actually using gunite by the client themselves did some ganiting for this particular column. We usually use the structural putty, but ultimately it's well and good hard concrete surface. Then you do the air blowing so that there is no loose material of concrete powder and all sticking to the surface of concrete. Then this putty application for smoothening. This is again the same putty that I talked to you earlier, M50 grade. M50 is the compressive strength of this putty if you make it up into a. So after this, you apply the primer so that the excessive consumption of saturant will not take place. Then you do the carbon fiber wrapping. The blue color that you see is the saturant of the FRP, and the black is the FRP itself, the carbon fiber FRP itself. These lines that you see in the vertical direction is because of the cross stitching, and the fibers are actually oriented along this direction, the red line that you see. So basically 4 layers as per design it was applied. And then after that, the sand pasting that we discussed earlier, sand pasting gives it this appearance. So the surface is now rough and inorganic, so that further any protection is required, like plastering is required. So you can do the plastering on the surface. Otherwise, on top of FRP, it will not the mortar will not grip. Okay, so that is why you need to do this sand pasting, and then you do the plastering. Done. End of story. You do the curing, the column, as it requires around 15 days, because the plastering and all need to be cured. Done. So you do the at the starting of the site execution, you do the planning, how much amount of time is required. You calculate the number of labors required. You need to calculate the amount of material to be delivered at this much amount of time. And you do the project planning, and that's how you finish off within a given amount of time. So what if the compressive strength improvement through the FRP is not enough, wherein we had only a requirement of increase in 10 MPa in this particular, but what if it is like quite high amount of increase in strength required? In that case, we go for a hybrid solution, for which I can show you how we typically do it. This is another video.
The columns of this RCC structure have a predefined load-carrying capacity. How do we strengthen these existing columns to take additional loads? Here is how. Step 1. Scan the column using GPR scanner to mark main reinforcements. Repeat the step for stirrups as well. The grid obtained would align with the actual steel bars. Step 2. As per retrofitting drawing, mark location of FR and high strength alloy plates and drill holes at both locations. Step 3. Cut grooves into the concrete as per the markings. Step 4. Perform surface grinding and anchor the threaded rods. Step 5. Apply primer and SRM structural adhesive. And press the alloy plates into the groove. Tighten them firmly using nuts. While grinding, round the column edges to 25 millimeters radius. Step 6. Apply a layer of primer and saturant, followed by application of SR and CRAM carbon fiber. Sanrachna, leaders in structural retrofitting.
So that was one of my 3D modeling and animation things that I tried. I hope you liked it. And yeah, basically what we learned from that is you have a hybrid solution that you can design for compressive strength improvement of columns, which is why is it called a hybrid? Because it involves high strength alloy plates that you saw, which will be the hero of the retrofitting, which will be the main strength provider, main compressive strength provider, and around which we provide the FRP wrapping, especially useful in case of rectangular cross sections and square cross section columns, because in that case hoop direction FRP will not contribute much compressive strength capacity. So in addition to all that, you can provide vermiculite plastering, which is a gypsum based plaster, can be provided on top of FRP for improving its fire resisting performance, wherein commercially, as per law, it is required to provide certain fire rating, as in the structure should retain its strength for a given amount of time, like 2 hours or 1 hour or 4 hours, based on the type of building, for which we can design how much amount of thickness of this plastering is required. Again, aspect ratio of column, as it increases 1. What is aspect ratio? Breadth to width. Okay. So if it increases beyond 1, as in if it becomes more rectangular, then the FRP's compressive strength capacity reduces. Compressive strength capacity. Okay, as in when you do it when you try to increase a column strength by using FRP wrapping along the hoop direction, and if the column's aspect ratio is very rectangular, then its contribution to compressive strength is reduced. That is what I want to convey. However, the shear strength does not reduce, because that happens not through a contact critical mechanism, it happens through a bond critical mechanism. Now, now we saw the different types of column strengthening. Now we go into the beams and slab strengthening, which are bond critical applications. See, this blue color rectangle is a side view of a beam. Okay, imagine it is simply supported. So a load is appearing like this, and FRP is basically a tension reinforcement. So you provide along the tension rebar, main tension rebar. Okay. So bond critical applications like for flexure and for shear, it requires the tensile strength of the substrate. What is substrate? The concrete, PRCC. Okay, should be at least 200 psi, pounds per square inch, which converts to 1.38 MPa. This is the standard requirement. Now let's go into this in a little bit of detail how it works. When the load is applied, beams bend. And that is how beams resist load. Beams resist the load by bending. Okay. So at the time of bending, you know that above the neutral axis, you get the compression, where the concrete is really good in compression. And in the bottom, you have tension. This for a simply supported, of course, like in the middle of the beam. And in the tension phase, since the concrete is not so strong in tension, it will create cracks there, and that is why we provide main reinforcement along this direction, because steel is what is the ductile material in RCC. And along this direction, since the cracks are forming and it is expanding in this way, you have, when you apply FRP along this direction, the FRP will also get tensed. FRP will also be pulled apart, and this pulling apart of FRP against along the direction of its fibers is what generates the resistive strength for retrofitting. I hope it is very clear. It has to be quite clear, as in the bond between the concrete and the FRP is what transfers this deflection onto the FRP, and this deflection, this tensile force, tensile strain, to be more precise, tensile strain is what creates the strengthening force in FRP, and that force is the resistance that helps in your retrofitting in flexure. This is again how we apply it. You see, imagine a simply supported beam. Your tension faces in the bottom. The fiber has to be along the main reinforcement. Neutral axis will be somewhere in the middle, and so this is in the tension phase. Okay, and for shear strengthening of the beams, you typically have a slab on top of the beam, so you get the three sides. Along the stirrups, your fibers of the shear strengthening along the direction of the stirrups. Combined, it will be like this. This is the typical scheme of beam strengthening. And for slabs, you have the main direction along this direction. Okay, so this is where the positive moment happens. So a sagging happens here. And if it's a continuous slab, you have negative moment on top of this. So that will be tension will be on top in that case, wherein you provide the FRP on top of the negative phase, hogging phase. Ultimately, only think of this way: wherever there is tension, you remove the loading, apply FRP, and then put the loading back on, and then it will work. So two-way slab strengthening, you have to do it in both directions. Okay, because two-way slabs are designed to take bending in both directions. That's it. Another case study, very international company has we have certain clause wherein you cannot disclose the name of what company it is, but I hope you can understand which company it is. And here we required some strengthening of slabs. Okay, so certain unloading and loading processes happen in this industrial building. Beyond the design capacity of the slab, we need to increase the strength of the slab. So for which there was no corrosion, it was a fresh building. There is no other damages to the concrete. So we had to do conventional jacketing on the top portion of the slab, okay, in the hogging phase, and we provided high strength alloy plates on the bottom of the slab. You're wondering why we didn't do FRP? We did not use FRP because there is a clause given in ACI saying that the initial, the existing concrete must be safe for 1.1 times of moment due to the dead load, the new dead load, okay, the increased load, dead load, and 0.75 times of moment due to live load, the increased live, which was not satisfied. Okay, so since the initial condition was not satisfied, you cannot do FRP. But we have so many other techniques. So likewise, concrete jacketing on top, high grade alloy on the bottom. Let's see how it is done. So in the bottom, we'll start. We start by doing the rebar scanning. So this engineer is holding the ground penetrating radar in his hand, and it basically shows where the rebars are there in the slab. Drilling, because we need to anchor the strength providing high strength alloy plates onto the bottom of the slab using chemical anchors, which are drilled into the structure. So at the time of drilling, we should not hit the existing rebars, which is why this initial scanning was done. Now these plates that you see on screen are the high strength Fe 450 grade alloy plates. Okay, and you, based on the scan locations and rebar locations, you make wherever you need to do the holes for chemical anchorage. and then you apply the structural adhesive, which is a M50 grade adhesive, and then you stick these alloy plates onto the slab bottom surface and anchor it using these bolts, chemical anchor bolts. Okay. Then on top of the slab, we went for conventional strengthening. So the cover concrete was removed. Okay, mark the grid coordinates, and then the cover of the concrete was removed. Top cover was removed. Rebar just above the existing top rebar, we provided this new mat of concrete, no, new mat of RC steel. Okay, so, rebar, steel rebar, FE 500 grade. And just putting this mat there is not enough. This has to be mechanically bonded to the existing concrete. How do we do that? By using L-shaped shear keys. So you can see here, drilling of holes had happened into this. See, here they are tying the rebar. Actually, the drilling is not shown. What happens after this stage on the left side is that you drill vertically into the slab. Okay, then you insert chemical anchor as shown in the right side. Okay, and then you place these L-shaped rebars. You can see on the left side picture there are some L-shaped rebars. Okay, which will basically anchor the concrete, anchor the rebar mat onto the existing part. And this anchorage of this L-shaped bar happens through commercial chemical anchors. There are many companies that manufacture it. And then once the rebar is done, you pour the concrete, and then this steam with the concrete. You need to leave it for curing, and then it attains the strength, and the top strengthening is complete for the slab, and bottom strengthening was done by steel plate anchoring. Slab is now strong. Now we come to the joint between the slab and the column. So kar diya, but how about this joint? If you increase the loading on the slab, and if the joint of the column and slab is not designed to handle that much of load, then ultimately you are going to this column is going to punch through the slab, if you're aware of punching shear. So that kind of failure is obviously not desired. So what do? We anchor rebars between the column and the slab, and we provide something called as a capital, column capital. Okay, so here again the same mechanism. You scan and find where are the rebars. You mark the rebars. You do the drills onto the slab and the column, sorry, to find out where the rebars has to be anchored. And ultimately you need this rebar cage. Okay, now rebar ready. Okay, how do you pour the concrete? Now this entire portion is ultimately going to be a capital. So you need to pour concrete onto it, right? So how do you pour it? There is always going to be a gap between this concrete and this top, right? So you make core cuttings in the concrete slab. So from the top of the slab, you put the coring machine, you cut cylindrical holes through this, and these holes you can see. Okay, see these black patches in this thing. It is actually a hole, through and through hole. Then you put the formwork, pour concrete from top of the slab so that it pours down through these holes, which was made earlier. And after curing and shuttering and everything, your concrete capital is ready, done. Okay, so that was the entire strengthening process that we did for this particular project. Slab strengthening from the top and bottom, and enhancing the column to slab joint using by preparing a capital. All right, now, oh yeah, I missed out one point. It was done using microconcrete. Microconcrete has 10 mm down aggregate, as I told earlier. Addition of 10 mm down aggregate. Okay, so you increase the amount of aggregate in this by adding extra. Now this is a bridge in Kolkata. It's a bowstring bridge. Basically, it's a quite wide bridge. Now what happened is, I can show you a video directly. You can see it from the video.
Much like the city itself, the bridges in Kolkata have a strong undertone of antiquity.
This is the type of construction which started in 1930s in India. One of the earliest examples of post-rail bridge. It is the top part which is in the shape of a bow or a arch, and the string is the bottom part, the tension member, which keeps the bow in position. The beauty of this structure is there will be no horizontal force onto the foundations.
In the inspection conducted by Kolkata Metropolitan Development Authority, or KMDA, this 24-meter long bowstring bridge found itself among the list of vulnerable bridges and flyovers. Intervention was inevitable. In August 2019, LASA was awarded the consultancy services of Chitpur Bridge. The state of the bridge was surveyed. Non-destructive tests were performed. The seemingly healthy bridge revealed a very active and prominent corrosion in selected areas. In the vertical hangers, soffit of the deck slab and cross beams, main steel reinforcements had lost its diameter at several locations. In short, the sectional strength of structural members were being severed by corrosion day after day. Adding to its woes, the neighboring Dala Bridge would be closed down and dismantled soon, sending substantial traffic to Chitpur Bridge. To prevent a catastrophe, the immediate repair and strengthening of the hangars was absolutely necessary, and it had to be done fast with due diligence. That was when Sanrachna came to the rescue. Sanrachna has decades of expertise in structural retrofitting and has undertaken countless bridge repair and strengthening projects. In Chitpur, we started off with short blasting for a clear picture of the underlying structural distresses. Delamination and spalling was detected and removed with hammer and chisel. The exposed rebars of the hangars were treated for corrosion, and section was rebuilt with high-strength microconcrete. The underside of the bridge was made accessible with platforms supported on structural steel sections. Short blasting was carried out. The laminated concrete removed, and pressure grouting was conducted for improving the microstructure of the beams and deck slab. Exposed bars were treated for corrosion, and sections were rebuilt appropriately. With the basic repairs done, we turned to strengthening. Ultra high-strength carbon fiber sheet SRM CRAB UT400 was applied for strengthening the hangars from all angles. The same SRM CRAB UT400 was used in the underside of the bridge for enhancing the strength of deck slab and cross beams. On the top, the base of the hangars were armored with a 1.2 meter tall covering block.
What the strained workplace of Sanrachna are doing is the process of transferring the load from the vertical concrete members, reinforced concrete members, on to the set of 4 metal bars, which you can see are threaded, and metal bars can carry a lot of tension. After observing the damage to the verticals, the bridge committee took a decision that the only way of making this bridge continue to serve is to make the concrete verticals defunct and instead introduce these vertical tension bars for carrying the entire load from the concrete onto the steel bars.
For retightening the nut, the post tensioning was permanently transferred to the hanger, making it safe for a lifetime. With the application of protective coatings on the bridge, our work was complete. Historic infrastructure rendered safe for the generations to come. Sanrachna, leaders in structural retrofitting.
Okay, so I hope I have covered most of your basics of structural strengthening, and we discussed concrete RCC strengthening in columns. In compressive strength improvement, we looked into the beams and slabs as well. We studied, we looked into the design aspect of FRP. like design calculations we just went through, and yeah, and you saw how project is basically executed for strengthening, for FRP strengthening. So now let's conclude quickly and open the forum for the questions. So basically, let me tell you, like in Flexure, the solutions that we provide are usually FRP laminates and high strength alloy strips with FRP wrapping, because usually when there is flexure requirement in beams, there is always some shear requirement as well. Because ultimately, your original design is going to be economical design. So cut to cut, the amount of rebar will be there for flexure as well as shear. So when there is additional loading, it will anyway, it will, you will require strengthening in the flexure as well as in the shear of a beam or in the flat slabs. Shear, you provide FRP wrapping as I showed earlier for columns, beams as well. Flexure usually in the columns, beams and flat slabs. Axial compression requirement mostly only in the columns. Beams usually doesn't come under axial compression as such as a full. So in case of axial compression, we give confining reinforcement with FRP, like we saw in the 5 dimensional columns. Then hybrid solution can be given if the cross section is squarish or rectangular, and then we can give FRP wraps. Like in columns you give main reinforcement and then you give the stirrups. So it's a good detailing practice to give FRP wraps, as in similar to the stirrups in the columns. Okay, nice. And yeah, this is how we typically give flexural strengthening. Okay, so the rebar, the FRP is along. Let me. Yeah. So the FRP will be oriented along the main reinforcement, okay, main flexural reinforcement, and below the nodal axis. And this little guy that you see as the face is basically the red dots are, the black dot is the existing rebar, okay, and on the sides, the black faces that I have marked is where you can provide the FRP. Basically, the FRP should be as far away from the neutral axis as possible. So only after you exhaust the bottom face of the column, you start applying FRP on the sides. Okay, so that the maximum amount of moment can be provided to the FRP by the FRP, so that farther away from the neutral axis is more efficient. That's a design. So now shear strengthening, you provide U-shaped wraps for the FRP for the beams, RCC beams. Why U-shape? Because you cannot go all the way around. Usually beams have a slab on top. Some beams don't, wherein it is in the towards the periphery of the buildings. Sometimes as the tie beams and all, you don't. Sometimes we can provide full wrapping as well for shear, which is obviously better, because ultimately stirrups have 4 side coverage, right? So after when there is a slab, you can only provide the 3 sides. That's how it is. We can't help it. Now, confinement for columns. For columns, circular cross section, you provide FRP along the direction of stirrups, so that it confines the column and prevents its lateral. It resists its lateral expansion, so that its compressive strength is increased. And if you go through the ACI code, it will, like in many places it is said in the ACI code that it's basically the clippings that you see here are basically like 5 different ways of telling you please don't use FRP in direct axial compression. So you can go through the codes for further understanding of this. And certain design practices that we maintain in practice is that you don't say that X amount of FRP is equivalent to Y amount of RCC, Y amount of reinforcement, steel reinforcement. That's not a good practice, because people misinterpret it, and it leads to bad structural performance ultimately. And then you have this splice. You cannot, when I showed you laminates, right? Like laminates are factory cured and it comes ready for attachment to the RCC. You don't you should not give splicing on it. Like lapping for the laminates is not recommended at all. Okay. So if you require, like say 20-meter long, if it's a girder, 20-meter long laminate is required, you manufacture it in 20-meter length and then you cut it inside as per the requirement and you apply it directly. You cannot splice it. Okay. You can't bring like one 10 or 10 meter and one 11 meter and then give a 1 meter lapping in the site and provide it. That's a wrong practice. FRP fibers is the fiber continuity is the main funda. Like fiber continuity is what provides you the strength. So don't cut the fibers. And on deteriorated concrete surface, dilapidated concrete surface, you cannot apply FRP because concrete has to be solid. All right. So these are the basic practices that we follow. In India also we follow all this. And see, if the moment requirement is greater than greater than the 40% strength of existing structure, if the shear strength requirement is more than 50% of the existing structure, axial strength if it is more than 20% of the existing structure, if that is the requirement, when these moment shear and axial requirements go more than this much of existing, then you go for some primary like sectional enlargement or providing the steel section. Don't go for FRP for more than this much amount of increase requirement. Okay, because FRP is always a supplementary reinforcement. Okay. There are some bridges which are constructed in US which has FRP rebar in it. So in that case, it is completely embedded and it has that kind of that amount of safety factor built into it. So as per design, they are doing it that way. But for retrofitting, that is truss construction that I was telling you, construction of bridge. But for retrofitting, these are the numbers, thumb rule that we follow.
Thank you, sir. Sir has elaborated many things in this webinar. What is retrofitting, material use, various techniques, structural deficiency, various design solution, FRP and RCC bonds, and also discuss the problem of many structures and the respective solution, and also elaborated various activities with the help of photos and videos. He also discussed various sites of retrofitting and strengthening. With his detailed presentation, all the participants might have explored the wide scope in this field. Now I request all the participants can post their questions in the chat box.
Sir, tell us about the safety measures in this.
So see, basically for any construction site, there are the measures that you typically use for safety of the people. One, you can see the personal protective equipments, which include the helmets, hand gloves, okay, and the high visibility jacket. This is basically required. You can see the workmen here, okay, they are all dressed in the PPE, and they have these boots as well. These are steel-tipped boots that they're wearing. So these are for the personal protection of these engineers as well as the workers who work there. Okay, gloves is very essential because you are dealing with epoxy. Okay, and second thing is you have this basic safety training which you give for all the employees, including the site engineers. Okay, so you can see this green helmet person who's working in there. That is actually a safety engineer. Okay. So what they do is they visit the site, and before the works of all these people happen, all our engineers as well as all our workmen are assembled at one place. They will explain to them about the hazards, safety hazards and health hazards that are possible in this particular given site based on the type of application of materials, as well as based on the behavior, based on the purpose of the building, like what kind of cargo or things come onto the site, if there is any production of cut fibers, asbestos, or inhalation hazards, right? Like there are, if grinding is required, what is the precautions to be taken? So for each activity, we have a set of safety personal protection equipments. Like if you're doing grinding, you have to wear goggles, safety goggles for your eye protection. You have to wear earplugs for your ear protection. You have to wear a nose mask. Even before the COVID times, the nose mask was required for these grinding. wherein fiber cutting, FRP cutting, as well as for concrete grinding, these measures have to be taken.
Yes. Sir, is there any specific Indian standard code for this
For safety,
confined which is or
we are not aware of that. Actually, we have one for jacketing, RCC jacketing. We have a code for RCC jacketing, which is Indian code. But typically, for design purposes, we always follow the tried and tested FRP design code, which is ACI 440. And we also have a European Union code, which is called the Euro code. They have FIB. FIB 90 is the European code for
90?
yeah, 9090.
Hmm.
FIB 90. You have to purchase it. It's around 10,000 Indian rupees. We have that with us.
10,000.
Yeah, you can design it based on that. But ultimately, the design that we do for our commercial purposes, we always follow the ACI, American Standard Institute. ACI 44017 is the code. I have mentioned it somewhere, right?
Yes, yes.
Yeah,
You are noted
ACI
it.
44017. How costly is this procedure? Okay. See, I am actually not the right person to talk about this because I am a design engineer, but I can tell you a few things about costing. See, the FRP that we used in this particular project, okay, this particular application required 4 layers of wrapping of 600 GSM carbon fiber. Okay, we also have places where you require only 1 layer of wrapping of 300 GSM. It's all based on the amount of loading as well as the dimension of the column cross section. So based on that, the expenditure required for wrapping can vary substantially between the projects. Okay, and what else is there? Like this is for FRP, and the same goes for strengthening using laminates. Okay, carbon laminates. Or if you are doing jacketing, RCC jacketing, the material that you use, like how much amount of thickness of jacketing is required. Based on that, the costing can change per square meter. How much what is the design strength of the jacket? Like if are you using micro concrete for jacketing, or is the thickness large enough so that you can pour the regular RMC concrete? In that case, the costing will be lesser. Okay, so based on a lot of parameters, the costing can vary. But what I can tell you is that the commercial application in Mumbai, especially, like we have around 10 or 12 sites running parallelly in Mumbai. So people have embraced the costing, how much amount of costing is coming up for this FRP wrapping, and it is suitable for the commercial applications of bridges and buildings, residential apartments, commercial apartments, everything. So it is not too costly, is what I can say at the moment. And for each different site, the costing varies drastically. That is one thing I can. Okay. While doing this practice, is there 100% assurance on serviceability criteria? Serviceability can be checked at the time of design itself. So it is, yes, serviceability is checked during. And if you're talking about amount of deflection, FRP application does not reduce the deflection, does not reduce the amount of deflection of a beam, because the deflection is based on the Young's modulus and cross-sectional area EI by like the stiffness you need to calculate, right? So increase of stiffness, it will depend upon the amount of cross-sectional area of FRP applied. So if you consider the cross-sectional area of concrete is huge as compared to the amount of FRP that you'll be providing. So the laminate has a cross-section of 100 mm by 3 mm. So you can see that's very minimal, and the amount of RCC concrete is there that is huge. So the amount of deflection will not be significantly affected by applying laminate. But so we obviously tell the clients beforehand itself. If you're coming for reduction of deflection, then you have to either increase the cross-sectional area of the member of the beam by doing jacketing, or by adding this structural steel to the bottom. Okay, so that is the serviceability thing. And if you're looking at cracking, see, it's again the design. Based on the design, we there is like a particular amount of crack width that is permissible. So yeah, that is already built into the design of FR. So you would anyway have a cross-checking for serviceability when it comes to flexure and shear. That is there in the design procedure. So it is, yeah, there is an assurance. But obviously you cannot give 100% assurance or anything, even for any commercial product that you buy from the market. Even if it's a pen, there is no 100% assurance. So yeah. But in practice, everybody has accepted the amount of safety and guarantee that we usually provide. For our company, we provide, based on the type of application, 10 to 15 years of guarantee we provide from our side. There was a question that says why we prefer NSM FRP than EBR. See, I'll tell you what NSM is. NSM is wherein you make grooves on the surface of the RCC member, and you insert material into it, insert the retrofitting material into it. We hang on. So what happens is that in commercial practice, you need to basically increase the strength. So wherein you apply it on the surface. Here you can see the FRP wrapping application applied on the surface directly. There is no grooving. So here we cannot call it near surface mounting. It is basically the direct surface mounting. So for laminate, you can see in ACI, I couldn't show you right now, but in ACI code, if you see, there is like a drawing of NSM wherein grooves are required, grooving and laminates are put inside, or if a reinforcement is put inside, there is NSM. But usually we don't do that. We have done around 2000 projects in retrofitting, and we have rarely done any NSM. We usually go for the surface application. How to select design the thickness of FRP and the steel required for jacketing. So for RCC jacketing, there is an Indian code itself. So based on that, you can find out how much amount of jacketing material is required. Thickness of FRP, as I said, like previously for this particular project itself, see this design calculation is there. All right. So step by step, you have to follow how to do the design, and it will tell you like how much amount of thickness of FRP is required. So it will come out as the number of wraps that you will need to provide. So more number of wraps means more thickness. It's a design procedure. It's a well-established procedure, so you can do that. That's how you do the FRP thickness. And what is it then? Indian code, we discussed that. In what conditions should we use this application? Are you asking about FRP application? Because for FRP application, the surface has to be structurally sound. Okay, so for applying FRP, be it laminate, be it FRP wrap, your surface need to be structurally firm. Should not be flaky. It should not be delamination. Like inside, if the reinforcement is under corrosion, then the surface of RCC will be flaky. Okay, so it will start peeling off, which will not work properly. In that case, loose concrete we chip off and we reach the parent concrete, the hard concrete, and on the hard concrete we do the profiling, like we apply micro concrete or polymer modified mortar, which are like M40, M50 strength material, concrete cement based material, and we apply that. We make the structure firm, hard, and there should not be any moisture on the surface at the time of FRP application. Then we go for the FRP application. At the time of application of FRP, you apply a layer of primer, And on top of the primer, we put either adhesive putty in case of laminate, or you put saturant in case of FRP wrapping. In both these cases, the material that is put is organic and it is not water based. It is not water based. So moisture should not be there on the surface. These are the things we need to notice we need to take care when FRP is applied. If we want to start to work in this sector, how can we start? What I mean, if you want to start working in this sector, like if you want to do a design, there are companies like our company, wherein we are one of the leading structural retrofitting providers in India. You can, our website is there. You can find our contact. You can talk to the HR. You can submit your resume and proceed directly. If you pass the interview, you can work with us. We actually have a requirement of structural engineer, so we can do that. And site application ke liye bhi, there are a lot of vacancies in the company because we have lot of projects running in pan India area. Like I showed you the bridge that was recently done in Kolkata. We have so many works in Kolkata, in Delhi, in Andhra as well. In towards the south, we don't have much projects, but there is one in Bangalore that is running. So there is a lot of retrofitting projects that is working, that is running, and requirement is increasing per year on year. So you can definitely find a career in retrofitting. If you that is if you want in India. I'm not very familiar with how it goes on into outside of India. There are many other companies as well, but ours, since I've been in this company for 3 years, I can tell you that it's a very good platform for a design engineer as well as for site execution.
Thank you, sir. Good afternoon, everyone. My name is Sampada Nanasai, studying in third year of civil engineering. Now I introduce Institution of Engineers Solapur Local Center Secretary, Engineer Mohan Deshpande, ME Mechanical Engineering. He is pursuing PhD in Mechanical Engineering. He is recipient of National Award as the Best Principal by Indian Society for Technical Education. He is currently working as Executive Director at Bharat Ratna Indira Gandhi College of Engineering, Solapur. He is past District Governor of Rotary International District. He is past National Executive Council member, IST. He has worked as past Chairman of Computer Society of India, Solapur in Solapur chapter. He is committee member of Mechanical Engineering Division. He is founder, director, and chief trainer of S Soft Skill Solutions. With this brief introduction, I request Engineer Deshpande sir to guide all the participants. Thank you.
All the dignitaries, particularly the speaker, Dr. Vivek, for conducting this session very nicely. Though I'm from mechanical branch, I listened to him very carefully. And may I suggest Speaker Vivek sir to organize the actually 3 days, 5 days workshop with practical demonstrations. We are ready to host such workshops in Solapur. Today, I'm going to tell you about few things about the Institution of Engineers. All my engineers, this IEI is a professional body of all the engineers throughout the world. And it established in 1920, almost a century it has completed and organizing a number of activities and the projects across the globe. All my engineers, may I appeal to you, please be part of the Institution of Engineers. Be positive in conducting the activities with the help of our IEI chapters. You can become membership right from technical associate membership, associate member, member, fellowship, based on your qualification and based on your experience. But today, lot of engineering and the diploma students, they are attending this particular workshop. So immediately after your graduations, you can join the membership of IEI. One of the biggest advantage of IEI is if you are diploma holder and after diploma, if you are doing the job, while doing the job, you can complete a graduation course of our IEI, that is AMIE, that is Associate Member in Institution of Engineers. And that AMIE is equivalent to your BE degree, that is equivalent to your BTech degree. Even you can have your PG. So while doing the job, you can complete this particular course. The classes are available. If you are from Sholapur, you please contact our local chapter. We will provide all sort of a guidance to you, and it will be a very nice opportunity. So once again, on behalf of our chairman, Engineer SM Sheikh, myself, Engineer Mohan Deshpande, and our member, Engineer Kirti Bhosle, I make an appeal to please become the member of IEI for your professional development. And I thank also the speaker, and also I suggest the speaker, Engineer Vivek, to organize the actual workshop that will be more beneficial to all the students. Thank you very much, and may I hand over mic to our convener, Engineer Kirti Bhosle.
Thank you, sir. Now I request Professor A.P. Khatri, sir, HOD of Civil Engineering, for delivering vote of thanks.
First of all, on the behalf of Department of Civil Engineering, I congratulate all the officials of Institute of Engineers Solapur local chapter for conducting a nice webinar on the retrofitting. Actually, in this era, we are going to go on high-rise buildings. And in case of high-rise building, confinement and retrofitting are the most important. And we are going to having the more applications of this confinement and retrofitting in the upcoming years. And I'm really thankful for all the officials of Institute of Engineers local chapter Solapur for providing us such nice platform for all the participants and giving them a very nice information on the retrofitting. Especially, I am thankful for Chairman Mr. SM Sheikh for providing us this nice platform so that we can go ahead. Secondly, I'm thankful for Engineer Mohan Deshpande sir, Executive Director, Bharat Ratna, Indira Gandhi College of Engineering and Research for supporting this activity. I'm also want to say that as you have appealed, we are going to motivate the number of students for participating for Institute of Engineers, and we'll aware them the importance that how they can get benefited for this Institute of Engineers. I also thankful Dr. Mangesh Joshi, CEO, Sanrachna Structural Strength Private Limited, for giving the permission to conduct this nice webinar. I am very much thankful for today's expert, Engineer Vivek SV. I should say that the webinar and the presentation was so nice that even civil engineer and other than civil engineer, local person or local student can also understood what is going on, and very nicely through the videos, through the PPTs. It's a very nice presentation, one of the presentation which I have seen. I am very much thankful once again for our expert, Vivek sir. I also thankful for our founder secretary TJ Sawant sir for providing us this platform. I am also thankful for our campus director Shira Sawant sir. I am thankful for our principal who always support us for this type of activity and motivate us. I am really thankful for faculty coordinator Bhosle madam She has taken the initiative in arranging this program and conducted the program nicely. I'm very much thankful for the madam. I'm also thankful for other teaching faculty of Civil Engineering Department, those who have taken the active participation in conducting this activity. Not only faculties, but our student coordinators, they have worked to make this event successful. And without the participant, this event cannot be successful. I am very much thankful for all the participants, those who have participated and listened this program very patiently. I'll thankful for all. Thank you. Thank you very much.
With respect to all the respected dignitaries, I conclude that this session is over.